Alright, so your test tomorrow is mostly on 8.5 and 8.6 stuff. There is a question about combinations, which is from, what was that, 8.4? Like the NCR questions where you just have to plug it in to the formula. And then there is a question about Pascal's triangle. So you guys can use your notes for the test tomorrow. Just make sure you have them on paper. And you need a calculator. Definitely need a calculator for tomorrow. So let's take a look at number 1. How many different batting orders can a baseball coach create from a team of 14 players when there are 9 positions to fill? So there's 9 spots. 3, 4, 5, 6, 7, 8, 9. How many people possible? How many options do we have for this first spot? We have 14 players total. So there's 14 people that could possibly be in our first position in our lineup. If you're that first person, you can't also be the second person in the lineup. You can't have a clone and be in both places at once. So that would leave us for 13 in the second spot, then 12, 11, 10, 9, 8, 7, and 6. Then we just multiply all of these numbers together, and we get 726,485,760. Any questions from number 1? Awesome. Number 2. Consider that 8 sprinters have qualified for the finals in the 100-meter dash in the NCAA National Track Meet. In how many ways can the sprinters come in first, second, and third? So first, second, and third are the 3 places we're looking at. How many different options do we have for people that could come in first place? 8. We have 8 sprinters total, so any of the 8 could be in first place. If you're in first place, you can't also be in second place. So how many people do we have as options for second place? 7, and then 6. Multiply these together, we get 336. Any questions there? All right, the next 2, we have distinguishable permutations. So that is the total, the factorial of the total number of letters we have over the factorial of the repeated ones. So in total, we have 1, 2, 3, 4, 5, 6, 7. 7 letters. So 7 factorial on top. Now we want to see what letters repeat. So L's repeat twice. So that would give us 2 factorial on the bottom. And A's repeat 3 times. So that would give us 3 factorial on the bottom as well. Now we just want to multiply this all out together. So 7 factorial is 7 times 6 times 5 times 4 times 3 factorial. We could stop there because we have a 3 factorial on the bottom. And then 2 factorial is 2 times 1. 3 factorials cancel. We can cancel out the 2 with 2 from the 4. So we're just multiplying 7 times 6 times 5 times 2, which gives us, anybody do this one? What'd you get? Awesome. 420. The next one is the same thing. Distinguishable permutations. We do the total over the repeated. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters total. So 10 factorial on the top. And then we put that over all the ones that repeat. So P's repeat twice, so that gives us a 2 factorial on the bottom. D's repeat 3 times, and E's repeat 4 times. Now we just multiply it all out. So 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial. We could stop there because we have a 4 factorial on the bottom. 2 factorial is 2 times 1. 3 factorial is 3 times 2. 4 factorials cancel. 3 times 2 is 6, so we can cancel those out with the 6 on the top. And then we can divide 10 by 2. That gives us 5. So we have 5 times 9 times 8 times 7 times 5. What do we get here? Awesome. 12,600. All right, let's go to the next. In a certain state, each standard automobile license plate consists of 3 letters followed by a 5-digit number. How many distinct license plate numbers can be formed in this state? So we have 3 letters and 5 numbers. 4, 5. I'm going to separate them because the first 3 are going to be letters, the second 5 are going to be numbers. How many different letter possibilities do we have for our first space here? 26. How many different letters do we have for our second space? 26. We could have A. It can repeat here, so we have 26, 26, 26. Now for our numbers, how many different possible numbers can we have in our first space here? 10. It can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is 10. What about our second space? 10. It can repeat. So 10, 10, 10, 10. So multiply all these together. We have 1,757,600,000. All right, next one. In 1963, the United States Postal Service launched the Zoning Improvement Plan, zip code, to streamline the mail delivery system. A zip code consists of a 5-digit sequence of numbers. So find the number of zip codes consisting of 5 digits. 1, 2, 3, 4, 5. How many different numbers can we have in our first spot? 10. What about our second spot? 10. It doesn't tell us we can't repeat. So we have 10 for all of our spots. Multiply all these together and we have 100,000. 1, 2, 5 zeros. So yeah, 100,000. B is the same thing, but it gives us a restriction. It says the second digit is 1 or 9. So again, we have 5 digits. How many possibilities do we have for our first spot? 10. What about for the second spot? How many? 2, because it's either a 1 or a 9. So there's only 2 options we could have there. What about our third spot? 10, 10, and 10. So here we have 20,000. All right, next. Yes. ATM personal identification number PIN codes typically consist of 4-digit sequence of numbers. Find the total number of ATM codes possible. So we have 4 spaces. How many different numbers could we have in our first spot? 10. What about our second? 10, 10, and 10. We have no restrictions here, so it could be any number and it can be repeated. So we have 10,000. Find the total number of ATM codes possible when the fourth digit is not 0. So again, we have 4 digits. How many possibilities do we have for our first spot? 10. What about our second? 10. Third? And fourth? 9. Because it can be any number except 0. So that takes away one of our possibilities. So we're multiplying it by 9 now. So this is 9,000. Any questions from the first page? A college student is preparing a course schedule for next semester. The student must select one of 4 mathematics courses, one of 4 science courses, and one of 2 courses from the social sciences and humanities. How many schedules are possible? So he's looking for 3 classes, a math, a science, and a social sciences. Three classes. How many different classes could we have in this first spot here? What number do we put there? How many options do we have for the first class? 4. Can be one of 4 math classes. What about our second spot? 4. It can be one of 4 science classes. And then our third spot? 2. Because it can be one of 2 social sciences. Multiply all these together, we get 32. Number 2, or I guess the second one on this page. Next one. A customer can choose one of 4 amplifiers, one of 9 stereo receivers, and one of 10 speaker models for an entertainment system. Determine the number of possible system configurations. So there's 3 things that we need: an amplifier, a stereo receiver, and a speaker. How many different amplifiers can we have? What number do we put in our first spot? 4. What about the second one? How many different stereo receivers can we have? 9. And then how many different speakers can we have? 10. Multiply these together, we get 360. Any questions on those? Alright, and how many ways can a 14-question true-false exam be answered? So there's 14 questions we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How many ways could we answer the first question? 2. It's either true or false. What about the second question? 2. So all of these are 2. All of them are either true or false. So 2 times 2 times 2, so it says 2 to the 14th power, which when we put that into our calculator, we get 16,384. All of these are 2. Any questions? All right. In a psychology class, a student must dissect 3 different specimens. The student can select one of 6 earthworms, one of 7 frogs, one of 3 fetal pigs, and how many ways can the student select the specimen? So this is just like the one, not above it, but like the first 2 on this page. So we have 3 different things that we're dissecting. What's going to go in our first spot? 6. Because they can select one of 6 earthworms. What goes in our second spot? 7. And then our third spot? 3. 6 times 7 times 3 is 126. Next, find the probability for the experiment of drawing 2 marbles without replacement from a bag containing 1 green, 2 yellow, 3 red marbles. Both marbles are red. So we're drawing 2 marbles. How many marbles total do we have? 6. So if we stick our hand in the bag, what is the possibility that it's red that we start off with? So the first marble we pick is red. 3 out of 6, because there's 3 red marbles to start. This says without replacement, so we're pulling out a red marble and putting it to the side. So how many marbles do we have left in the bag? 5. And out of those 5, how many are red now in the bag? 2. Because the first one we picked was red. So we're only left with 2. Now we are picking 1 red marble and another red marble. So are we going to multiply these or add them? Multiply. Because it's not 1 red marble or another red marble. It's 1 red and another red. So we multiply. So 3 times 2 is 6. 6 times 5 is 30. Always simplify your fractions. We get 1 over 5. If you want to, you can leave it as a decimal or a percent. So either way would work. 1 divided by 5 would give us 0.2. So if you put 0.2 as your answer, totally fine. Or 20%. Any questions there? All right, next, find the probability for the experiment of drawing 2 marbles without replacement from a bag containing 3 green, 3 yellow, and 4 red marbles. So neither marble is yellow. How many marbles total do we have in our bag? 10. 3 plus 3 plus 4 is 10. Now what's the probability that we pull one out that is not yellow? To start. Out of our 10, how many are not yellow?
7.
7. Now it's without replacement, so we're pulling a non-yellow one out, putting it to the side. How many marbles do we have left in our bag? 9.
6.
Well, we have 9 total,
9.
but 6 of them are yellow, or not yellow. Because the first one we pulled out was yellow, so now we have 1 less. The first one we pulled out was not yellow, so now we have 1 less non-yellow one. Any questions so far? Okay. Are we going to add these or multiply? Multiply. Because we're pulling 1 non-yellow marble out and another non-yellow marble out. So and means we multiply. So 7 times 6 is 42. 9 times 10 is 90. Simplify this to 7 over 15. Again, you can leave it as a decimal or percent or a fraction. Any questions there? All right, find the probability for the experiment of selecting 1 card from a standard deck of 52 playing cards. The card is a face card. How many face cards do we have in one deck?
12.
12. So probability that we draw a face card is 12 out of 52. Can we simplify 12 over 52? What does it simplify to? 3 over 13. Yeah, you can divide both by 4. Next one, find the probability for the experiment of selecting 1 card from a standard deck of 52 playing cards. The card is a black card. So we have 52 cards total. We want a black card. How many black cards do we have in the deck? 26. We can simplify this to 1/2. Next one's the same thing, but the card is numbered 2 through 10. So again, we have 52 cards total. How many cards do we have in the deck numbered 2 through 10? 36, awesome. 2 through 10, there's 9 cards, so 9 cards from each suit gives us 36. So we can simplify this to 9 over 13. Yeah. Use the table which shows the age groups of students in a college sociology class. So a student from the class is randomly chosen for a project. Find the probability that the student is the given age. So we're looking for younger than 22 years old. How many students total do we have? 39. Just add them all up. We have 39 total. Younger than 22 would just be 19 from this group of 19 or the group of 17. So
36.
36. Perfect. So we get 36 over 39, which simplifies to what? (12 over 13). Awesome. Next, one card is selected at random from a standard deck of 52 playing cards. Use a formula to find the probability of the union of the two events. So the card is a face card or a black card. So we have 52 cards total. How many face cards do we have in the deck?
12.
12. And then how many black cards do we have?
26.
26. Do any face cards or black cards overlap?
Yes.
How many?
6.
6. We have 6 face cards that are black cards. We have to subtract the overlapping. And it says or, so does that mean we're multiplying or we're adding?
Adding.
Adding. So our denominators are all the same. So we just add our numerators. 12 plus 26 minus 6. Hello. (32). Yep. Does 32 over 52 simplify?
8 over 13.
8 over 13. Awesome. We have to subtract the ones that overlap. So for face cards and black cards in the deck, there's 12 face cards, 26 black, but 6 of the face cards are black cards. So we're counting 6 of them here, but we're also counting 6 of them here, so we're counting it twice, so that's why we have to subtract what overlaps. Any other questions on that one? Alright, one card is selected at random from a standard deck of 52 playing cards. Use formula to find the probability of the union of the two events. The card is a heart card or a diamond. So how many cards do we have with hearts on it? 13. And how many cards do we have with diamonds? 13 as well. Do any cards overlap? Do we have any that have a heart and a diamond on it? Nope. They're 2 different suits, so none of them overlap. So we're not subtracting anything. It says or, so do we add or multiply? Add them. So 13 plus 13 is 26 over 52. What does 26 over 52 simplify to? 1/2. Any questions on that one? Alright, next one. A student from the class is randomly chosen for a project. Find the probability that the student is the given age. So we're looking for 18 to 21. So it's going to be from one of these. How many students total do we have? 30. And how many students are from the age 18 to 21? 26. Can we simplify 26 over 30?
Yeah,
13 over 15. Alright, next one. You can answer any 16 questions from a total of 20 questions on an exam. And how many different ways can you select the questions? So here we have 20 questions total, and we're choosing 16. So it would be 20, choose 16. So one of those combination questions. So our combination formula is n factorial over n minus r factorial times r factorial. Remember, the first one's always your n, second one's always your r, because n comes before r in the alphabet. So we have 20 factorial over n minus r would be 4 factorial times 16 factorial. We can multiply this out. On top we have 20 times 19 times 18 times 17 times 16 factorial. We can stop there because it'll cancel out with the bottom. On the bottom we have 4 times 3 times 2 and 16 factorial. Cancel out whatever we can. Let's see, 4 goes into 20 5 times. 3 goes into 18 6 times. And 2 goes into 6 3 times. So we're multiplying 5 times 19 times 3 times 17. What do we get? $4,845. Yes.
How did you know you had to do like the plug it into the formula that you see?
So the next one's the same way. We have a group of 30 people, but we're only picking 12 of those people. So we have 30, but we're only choosing 12. So again, we plug it into the formula. We have 30 factorial on top over 18 factorial. N minus r would be 18 times 12 factorial. So we'll multiply this all out and we get 86,493,225. Alright, last one on this page. A law office interviews paralegals for 10 openings. There are 15 paralegals with 2 years of experience and 12 paralegals with 1 year of experience. How many combinations of 6 paralegals with 2 years of experience and 4 paralegals with 1 year of experience are possible? So, out of the 6 paralegals that we want, we're picking from this group of 15. So we have 15, but we're choosing 6. And then from the 4 paralegals we want here, we have a group of 22. So we have 22, but we're choosing 4. So we do the same thing that we just did before, but twice. So 15 choose 6. We have 15 factorial over 15 minus 6, which is 9 factorial, times 6 factorial. So on top we have 15 times 14 times 13 times 12, 11, 10, 9. And 9 factorial times 6 times 5 times 4 times 3 times 2. 9 factorials cancel. We can cancel out 15 with 5 times 3. And 6 times 2 is 12. So on the top, we have 14 times 13 times 11 times 10 divided by 4, which gives us 5,005. We do the same thing again for our second one. So we have 22 factorial on the top. 22 minus 4 is 18 factorial times 4 factorial. So on the top we have 22 times 21 times 20 times 19 times 18. On the bottom we have 18 factorial, 4 times 3 times 2. Eighteens cancel. 4 and 3 are 12. We can't cancel that out. Look, 4 goes into 25 times. 3 goes into 21 7 times. And 2 goes into 22 11. So 11 times 7 times 5 times 19 is 7,315. So we have two different numbers here. What do you think we'd do with them? Do you think we add them or multiply them? Read the question. What do you think? Do you have any keywords that tell us what to do? What makes you think multiply? Because it says and. So we multiply them. So we get 36,611,575. In 2013, there were approximately 11.46 million unemployed workers in the United States. The circle graph shows the age profile of these unemployed workers. Estimate the number of unemployed workers in the 25 to 44 age group. So we're just looking at this age group. We have 39%. What do you think that 39 is out of? What's going to go on the bottom? 100, because we're dealing with percents. It asks us for the number of people, not just like the probability of picking one of those people. So what do we have to do with this 39 out of 100? How do we find the number of people?
Multiply it by 11.46.
Awesome. We multiply it by the total number of people that we have, so 11.46. That gives us 4.47. Now, it's not just 4.47 people. We are dealing with millions of people. So make sure you put your unit. Any questions there? All right, next. Estimate the number of unemployed workers who are 25 years or older. So we're doing the same thing, but we're looking at more pieces of our pie here. So we have 25 to 44 is 39%. 45 to 64 is 29%. And 65 and older are 3%. So those are all the people that are 25 and older. We do the same thing we did in our last one to find the total number of people. So we multiply by 11.46. What do we got for this one?
I got
8.09. I got 8.14.
I think I only multiplied by 11.4 by accident.
Oh, okay. That would make sense. Any questions on that one? Alright, C, what is the probability that a person selected at random from the population of unemployed workers is in the 16 to 19 age group? So we're looking here. What do you think our probability of picking one of these people are? Yeah. So 12%. We could also say 12 out of 100, which would simplify to 6 out of 50, which is 3 out of 25. Or you could say 0.12. Either way works. Next one, what's the probability that a person selected at random from the population of unemployed workers is 20 to 64 or older? So 20 to 6 or 65 and older? Yeah. Oh no, 20 to 64 years. I wrote over the question so I couldn't see. So these are 20 to 64. These are 20 to 64, and these are 20 to 64. So we have 17%, 39%, and 29%. So we add these up, and we get I think it is 85. Yeah. 85%. Or we could say 85 out of 100 and then simplify. Last one. What is the probability that a person selected at random from the population of unemployed workers is 45 or older? So these people are 45 or older, and these people are 45 or older. So we have 29% plus 3%, which is 32%. Or we could say 32 out of 100 and simplify that. Or 0.32. Remember, probability can be given as a fraction, percentage, or decimal. You have one question that you have to do that, NCR. That's what it means by calculate the binomial coefficient. And then expanding using Pascal's triangle. Pascal's triangle will be given to you on the test. Remember that like the NCR ones can be written as like N over R. So if you see it written this way, it's the same thing.